Good morning, all. Our today's point is from the kinematics, and it is the fourth point. So, write down part first, second point, kinematics, in which it is a fourth point. Uniform circular motion. Uniform circular motion. Uniform circular motion in bracket UCM. This is our today's first point. Write down uniform circular motion. Now the question will be asked on this point as, write down the question, what is UCM? What is UCM? This is a question. It is an IMP question. Now the answer of this question is expressed in terms of the points for our simplicity. First point is definition. Now, the definition of the uniform circular motion. This definition is formed by using the definition of the circular motion. We know that the definition of circular motion, the motion of a particle along the circumference of the circle. Only one sentence is added in that definition, and it is with a constant angular or linear speed. So the definition is the motion of the particle along the circumference of a circle with a constant linear or angular speed is called uniform circular motion. So write down this definition. The motion of the particle, along the circumference of a circle, along the circumference of the circle, along the circumference of the circle with constant angular or linear speed. With constant angular or linear speed is called uniform circular motion. Is called uniform circular motion. In bracket, that is UCM. Please prepare your notes while watching this video. Now in the first point, we see the definition, the motion of a particle along the circumference of the circle. Now the second point is the example of the uniform circular motion. So write down the second point. For example, write down example. Examples. Now first example is the motion of Earth around sun. First example is the motion of the earth around the sun. And the second point is, and the second example is the motion of tip of hand of a clock. Tip of hand of a clock. Write down these two examples. First is the motion of the earth around the sun. Motion of the earth around the sun. The motion of a tip of hand of a clock. Now the third point of this answer is linear radial or centripetal acceleration in UCM. Third point is linear radial or centripetal acceleration in UCM. This is our third point, linear radial or centripetal acceleration in UCM, in which first point is formula. First point is its definition. It's a definition. First point is its definition. The particle performing uniform circular motion, or write down UCM, is acted upon by an acceleration. Which is in the point linear radial or centripetal acceleration in UCM. There are points. First is its definition. The particle performing UCM is acted upon by an acceleration which is along the radius and directed towards center of a circle is called linear or radial / centripetal. Linear, radial or centripetal acceleration. Or centripetal acceleration. Now this is A point. Now our point B is the formula for linear, radial or centripetal acceleration. Write down the point B formula. Now the formula is AC is equal to V omega is equal to V square upon R is equal to, formula first write down, this is first formula, or R omega square. These are the three different forms of the centripetal or radial acceleration in UCM. Unit is meter per second square. Now this is the second. In UCM, formula is V is equal to R omega, or V bar is equal to omega bar cross R bar. This is also important formula in UCM. It is the formula for the relation between linear velocity and angular velocity. Write down these two formulae. Linear velocity and angular velocity. Now the C point is direction. Direction of point C is the direction. We know that the direction of linear, radial or centripetal acceleration is along the radius and towards the center of the circle. Write down the direction of linear, oblique radial, oblique, write down it is only in short form, write it as it is along the radius, it is along the radius and it is along the radius and it is along the radius and directed towards the center of the circle, and directed towards the center of the circle, and it is shown in this diagram. So draw this diagram in order to understand the direction of centripetal, radial or linear acceleration. It is along the radius and towards the center of the circle, while R bar is directed away and the velocity is along the tangent. This is a linear velocity, this is linear or radial or centripetal acceleration, and this is the radius vector. So for detailed understanding, right here AC bar, the angle between AC bar and AR and R bar is 180 degree. Right here point, angle between AC bar and R bar is 180 degree. Now in the question, what is UCM? The answer is expressed in 3 steps. First is its definition. Second step is the example. Third step is the linear, radial or centripetal acceleration, in which there are sub-steps. A is its definition, B is formula, C is its direction. Up to this point, we complete the answer of uniform circular motion. The next point is, what is a period and frequency in UCM? It is an additional point and it is helpful for the numerical point of view. So write down this question. What is a period and frequency in UCM? Write down this question. What is a period and frequency in UCM? First write down period. In bracket capital T. It is the time required. Write down and prepare notes simultaneously. The time required to complete the time required to complete one revolution in UCM is called period of UCM is called period of UCM. Now its expression. Write down the next point, expression. In this expression, if velocity is equal to distance divided by time, and therefore time is equal to distance divided by velocity. And in this case, write down, in this case, time is period. Distance is equal to circumference. And velocity is a linear velocity. And so the formula for period becomes T is equal to, in this case, time is equal to period, distance is equal to circumference, and velocity is equal to linear velocity, and therefore T is equal to 2 pi r divided by v. This is the first important formula for the period. Now, if v is equal to r omega, then the formula for the period is 2 pi upon omega. This is the second important formula, because v is equal to r omega. Write down there, because v is equal to r omega. SI unit is second. Write down here, SI unit second. Prepare your notes while watching this video. Our question is, what is the period and frequency in which we completed first point period? Its definition, formula and unit. Now this is our second point, frequency. Frequency in bracket N or F. See first its definition. The number of revolutions per unit time. The number of revolutions. The number of revolutions. The number of revolutions. The number of revolutions per unit time. Per unit time. The number of revolutions per unit time is called frequency. Is called frequency of UCM. Is called the frequency of UCM. Write down simultaneously the definition. The number of revolutions per unit time is called frequency of UCM. Now its expression. Right here, expression. If N means frequency is equal to the reciprocal of the period, therefore from equation 1 and 2 we get, therefore from 1 and 2 we get, therefore from 1 and 2 we get N is equal to V upon 2 pi r. This is our third equation and it is for the frequency. Next is omega upon 2 pi. This is our fourth, and from equation number 4, the very important equation becomes omega is equal to 2 pi n. This is the fifth point and it is also important equation. So write down SI unit. SI unit. It is hertz or CPS or RPS. CPS means cycles per second and RPS means revolutions per second. And this is an additional point for the numerical point of view, and we completed this point. Now our next point is the fifth point in the kinematics, non-uniform circular motion. So write down point first. Main point is kinematics range. The fifth point is write down 2.5. Non non-uniform circular motion. It is our fifth point in the kinematics. Non-uniform circular motion. Question will be asked on this point as what is a non-UCM? What is a non-UCM? The question is what is a non-UCM? And the answer of this question is also expressed in similar manner as that of UCM. First point is definition, then example, then direction, formula, etc. And the definition of non-UCM is similar as that of the UCM, only difference is linear speed is variable. So write down the answer. First point is definition. Write down the definition and also prepare your notes while watching this video. Write down the motion, the motion of a particle, the motion of a of particle along the motion of a particle along the motion of a particle along the circumference of the circle. Circumference of the circle. Motion of the particle along the circumference of the circle with variable linear or angular speed is linear or angular speed is is called non-uniform circular motion. Is called non-uniform circular motion. Non-uniform circular motion. This is our first point and it is the definition. Now, the second point is its example. So write down, for example, the motion of a tip of a blade of a fan. The motion of a tip of a the motion of a tip of a blade of a fan. Blade of a fan. The motion of the tip of a blade of a fan. Write down the example. The motion of a tip of a blade of a fan at at the time at the time of start or stop. Start or stop. This is an example of a non-use. Now, as already stated, our next point is third point, the acceleration. Now the acceleration in UCM is the acceleration in non-UCM, the acceleration in non-UCM is due to is due to now the acceleration in UCM is due to change due to change in change in both magnitude magnitude as well as as well as direction of linear velocity as well as direction of linear velocity direction of linear velocity. So the resultant acceleration the resultant acceleration has two. So the resultant acceleration has two components. Has two components. Now, our fourth point is formula. A bar is equal to AC bar plus AT bar. Write down this formula. A bar is equal to AC bar plus AT bar. Where AC bar is the component of centripetal or radial acceleration. It changes the direction of the linear velocity and it is along the radius or towards the center of the surface. So write down where where write down where AC bar is the component of centripetal component of centripetal or radial where AC bar is the component of centripetal or radial acceleration. Component of centripetal or radial acceleration. It changes the the direction. It changes the direction of velocity, direction of velocity. It changes the direction of velocity and it is along the radius and directed towards the center of the circle. And it is along the radius and it is along the radius and directed towards the center of the circle. Directed towards center of circle. And it is along the radius and directed towards the center of the circle. And another component which is called as a tangential component. And AT bar is a component of tangential is a component of tangential acceleration. Component of tangential acceleration is the component of tangential acceleration. It changes the magnitude. It changes the magnitude of velocity, which is along the tangent, which is along tangent. And the next fifth point is the magnitude of the resultant acceleration. Magnitude of resultant acceleration. And the formula is, it is given to you, which is not in your textbook, but it is very important in case of the numerical point of view. So write down this formula, where AC bar is perpendicular to AT bar. Formula. Now, our sixth point is the direction. The direction of A bar is along diagonal of AC bar and AT bar, and it is shown in this figure. So draw this figure. In which centripetal of radial acceleration AC bar is along the radius and towards the center C. The tangential acceleration AT bar is along the tangent and the angle between them is 90 degree. But here along the diagonal show this a resultant acceleration A bar. So draw this figure properly. Now write down the seventh point, the direction of angular acceleration in non-UCM. Write down the seventh point, the direction of angular acceleration in non-UCM. And it is our seventh point, the direction of angular acceleration in non-UCM. So write down the seventh point, the direction of the direction of the direction of the direction of angular acceleration, angular acceleration alpha bar in non-UCM. The direction of angular acceleration alpha bar in non-UCM. And it is shown in this figure. So draw this figure. It is shown in this figure. Before the figure, write down the direction. The direction, the direction the direction, the direction of angular acceleration. Write down the direction of angular acceleration in in non-UCM, in non-UCM is also along the axis of rotation, axis of rotation, and and the direction of angular acceleration in non-UCM is also along the axis of rotation and and perpendicular to the plane of circle and perpendicular to the plane of the circle, but but not determined by right hand rule, right hand rule, but not determined by right hand rule. It is taken as it is taken as positive. It is taken as positive. It is taken as a positive if angular velocity increases and 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 taken as negative if angular velocity decreases. And it is shown in the following figure, and it is shown in following figure, and it is shown in following and shown in following figure. So write down this figure. Sorry, draw this figure. Here omega bar positive, alpha bar is also positive, angular velocity increases, angular velocity increases. Draw this figure. Angular velocity increases. And write down, sorry, draw the another figure. Omega bar, omega bar, and minus alpha bar. Angular velocity decreases. Angular velocity decreases. Angular velocity decreases. Draw these two figures. First is for negative alpha bar in which, sorry, positive alpha bar in which angular velocity increases, and another is a negative angular acceleration if angular velocity decreases. So up to this point, we completed a question, what is a non-UCM? And in terms of points, first point is definition, then example, then nature of acceleration, then its formula and direction. Now, the last question in this point or kinematics is, what is the difference between UCM and non-UCM? So write down this question. What is the difference what is the difference between what is the difference between difference between UCM and non-UCM? This is our question. What is the difference between UCM and non-UCM? So we already know that the answer of this question is expressed in terms of two columns. First column is, draw this table. First column is for UCM and the second column is for non-UCM. So draw this table. First column UCM and second column non-UCM. Draw this table. UCM and non-UCM. Let us see first point in UCM. In UCM, we know that the linear and angular speed is constant. The linear and angular, the linear and angular speed are constant write down here the linear first point in non-Euclidean. The linear and angular, the linear and angular speeds, write down speeds, are not constant, are not constant or variable. In museum, the period and frequency is constant. The period and frequency, write down in short, the period and frequency are constant. Here, the second point is the period and frequency are not constant. The period and frequency, the period and frequency are not constant. Now the next point, sorry, this is the second point, and the next point is the third point. Here, this is the second point. The angular acceleration, the angular, write down shortly, acceleration alpha bar is 0 because omega bar is constant. Because omega bar is constant. Here, write down the third point in non-Euclidean. The angular acceleration alpha bar is not constant. Sorry, is present. Is present. Present. Now the next point in UCL. The resultant acceleration has only centripetal or radial component. The resultant acceleration has only radial or centripetal. Only radial or centripetal component. And tangential component, write down shortly, component is axis. That is 80 bar. That is 80 bar is equal to 0. This is the fourth point. Write down here. Fourth point. The resultant acceleration has both radial and tangential components. Both radial and tangential components. That is, A bar is equal to AC bar plus AT bar because radial and centripetal components are same. In this way, by using 4 points, we express the answer of the question: what is the difference between UCM and non-UCM?